Good afternoon and welcome to the next presentation. And now we have Shoaib from the University of Essex, and he's going to give a presentation about advances in text analytics. So Shoaib, over to you. Thank you very much.
Thanks, Edmund. Thanks for the introduction as well. So I'll be mainly talking about something which is very popular in text, which is finding some kind of a thematic patterns and finding the meaning of the words through data analysis. So we are doing some kind of a co-occurrence analysis on the document that we have, and then we try to find out what a word means in certain, let's say, low dimensional space. So that particular technology is known as word embeddings in natural language processing, where what people do is use huge amounts of text collection, and then they try to run a computational model on it to find some inherent meaning, what the words in the collection are all about. So there have been methodologies which try to find out whether the models are good enough for, let's say, word analogy, whether they are good enough for word similarity. Word analogy, let's say man to woman and king is to queen, for instance. I have an example over here where you build spaces, low dimensional spaces, where automatically, if you have a point which is king, if a vector is drawn from king, it leads automatically to queen. So this is very remarkable that these word embedding models automatically learn from the data. Similarly, they capture verbs as well, walk to walking, and then even countries and capitals. So they can do it very effectively and even efficiently when they are trained on large document collections. So there have been very many popular models for learning word embeddings. I proposed some myself, and some of the methodologies. I don't want to advertise myself over here. So some of the very good methodologies which exist from other authors are, let's say, global vectors from Stanford University that came up, and then word2vec, which contains a skipgram and continuous bag of words from Google. So there is an extension to these word embeddings known as conceptual spaces, which was proposed a while ago, which tries to learn some kind of a pattern, which represents clusters in some low dimensional space, and these clusters could be convex regions, as we see in this diagram. For instance, there is a region which is a region for spiders, which try to model what different types of spiders are there, and then there are certain directions which are the properties, which represent some kind of a property of the of certain entities. So these conceptual spaces mainly model entities and how those entities are actually linked to these features or directions, as we call it. So for instance, as we go along this particular direction that is dangerous, things will get more and more dangerous. For instance, rattlesnake is more dangerous than cardinal spider. Similarly, sheep is larger than cardinal spider. So these properties are automatically captured by using computational models which capture these conceptual spaces. Now, what happened previously was in Gardenford's work, they actually used manual methods to generate such conceptual spaces. Now we have huge amounts of text. We want to develop methods which could automatically do this. So there have been efforts to do such to develop such computational methods or machine learning models to automatically learn certain conceptual spaces. For instance, people used these domain-specific documents from movies, and then they try to model these conceptual spaces for movies. For instance, as we go along a particular direction known as more scary, the movies get more and more scary. For instance, The Ring is scarier than the Shawshank Redemption. So very, very remarkable properties are captured by these conceptual spaces. But again, the problem was they were learned on domain-specific data, and then they were used on small text collections. But nowadays, we have huge amounts of text collection which can actually exploit. So this is a work which I proposed in 2017, where I tried to learn conceptual spaces from domain-independent data. And what used to happen was that automatically the organization moves in such a way that domain-specific clusters or subclusters are formed within the spaces, and the computational model is able to automatically do this without any human intervention. So then we could actually model different domains in a domain-independent space. So we did this on a very large scale using Wikipedia document collection, and then we got very nice results which we published in a top conference that is SIGIR in information retrieval. And then we even showed state-of-the-art results in entity retrieval tasks. Now the question is, like, how do these conceptual space advance the field of text analytics? These conceptual spaces right now are still very widely studied topic, and my works have spawned some new research directions in conceptual spaces. For instance, where they're useful, especially for industries and even in the academia. For instance, if somebody enters best laptops of 2021, Google may find it very difficult to search certain entities. Just if you give some the queries like this. Why? Because Google does not organize their spaces or their semantic spaces in such a way that they can retrieve results which can rank best laptops. Yes, they do look at these review websites. The problem is those review websites could be manipulated. People can pay money and rank certain laptop better than the other. Similarly, finding which city is south of London, we know using knowledge bases, people can know which let's say which place is south of London, or which place is in London, or which place is closer to London. But they cannot say which place is north or south or east or west of London. Even current technologies such as Google cannot do this. And then let's say famous movies of 2021, but less scary. If we model conceptual spaces, we can actually retrieve results. And this is what I have shown in some of my recent papers, that we can actually do such critique-based search, which even existing search engine technologies cannot do. And then there are other examples as well. Let's say, what are the most scenic places after Edinburgh? So we want to rank entities which are more scenic after Edinburgh in the UK, for instance. So this is where these conceptual spaces are very useful, and it can also solve many existing problems in search technology, in e-commerce, in let's say in product ranking. So these are some of the advances that conceptual spaces actually made in the field of text mining and natural language processing. So this is all from me, just to give you a brief overview of these conceptual spaces and where we are heading to with these conceptual spaces. So thank you.
Brilliant. Thanks, Shoaib. It's really interesting stuff. And I do like the fact that Shawshank Redemption was mentioned there, which is my, I think, favourite film of all time. So it was scary at parts, but I do get that. So thanks. So I've got a few questions for you on the back of that. And the first one is like a kind of fairly big one. Now, it's brilliant we've got everyone joining us at this conference today, and we're looking at like not just here and now, but also what is the future. So I want to start off with a question about the future, and really that is, what do you think is the future of conceptual spaces? What's your view on that?
Okay, so recently Google wrote a blog where Google has recently come up with very nice language models known as contextual language models in natural language processing. One of the very popular ones is BERT. There are other companies as well which are training such contextual language models, and they are spending millions of dollars into training these models. What is still these contextual models? First of all, have been very popular in many natural language processing, and they have outperformed all the existing methodologies that existed so far. What these contextual language models still do not encode is these conceptual spaces, the knowledge that we can get from conceptual spaces. That, let's say, which city is or which state is south of North Carolina. So this is the example that they use. I think it was either South Carolina or North Carolina. So Google said that still these contextual language models cannot encode such knowledge. In fact, if we fine-tune these contextual language models using these conceptual spaces, perhaps we can encode such knowledge in these contextual language models and maybe make them even more effective in other tasks as well. For instance, in search engine ranking. So this is one of the very nice applications that I could think of.
Yeah. Okay. I mean, it's a fascinating space, and there's so many changes that have happened in the last few years, and obviously, the future of search is much more complicated, exactly. Much more refined. So I'm going back to what you just said there about conceptual spaces. So how can anyone learn such conceptual spaces on their data?
Okay, if you have let's say domain specific data, or even if your company runs a domain independent data, one way would be to just use a named entity recognizer, find out the named entities, and then simply use this conceptual spaces model, which takes unstructured text data and let's say list of entities that you've detected through these named entity recognizer, and then simply model your data on your company or on your organization's data. So it's not that difficult to model these conceptual spaces, and then you can get a lot of insights about your organization through this company, through these data. For instance, if you're working for the police department, you can use the local data, let's say of a certain area, to find out which area or which region or which locality or which neighborhood is more crime prone than the other locality, or which locality needs let's say more shops or restaurants than other localities. So conceptual spaces can actually be used to model such knowledge, model such data to get knowledge to make certain decisions.
And it's interesting to say about the crime and looking at data and stuff. We in BT, we do a lot of stuff with lots of different police forces, for instance, and they always have a challenge of taking contextual knowledge around their data. They have lots of data, but actually, what does it mean? How does it relate to each other? And how do they also join to other pools of data around the UK? Do you just taking that as an idea? Have you ever seen anything within the law enforcement where actually they've used these kind of methods to actually look at data and really give them the right contextual information around it? Have you seen that at all?
No, right now, no. In fact, 2 months ago, the police, the crime branch, if I remember the name very well, they contacted the University of Essex. They wanted to get in touch with certain academics who are doing some research into data analysis and machine learning, and even computer vision as well. So that's where I proposed to them that we can use these conceptual spaces. I sent them these these images that I drew, how these conceptual spaces could be used to map certain regions according to their, let's say, level of crime. So yeah, I think we are in discussion with the police department recently, the local police department recently, to use such conceptual spaces on their data.
Yeah, and interesting enough, I think I might know who you're talking to. I love the fact that we're all connected, and this is sometimes around, the contextual information and contextualization of people around that information is very key as well.
Exactly.
If you haven't got the right people and the right data connected with the right organizations, then it's just separate data. So another thing, we've got 3 minutes left now. So what do you think of the other most cases of conceptual embeddings? What do you think of the most cases of conceptual embeddings?
Okay, let's go to Amazon, because when I presented this work, one guy from Amazon came in, and then he said that we actually see lots of such queries in our Amazon query logs. Let's say best laptops or best creams. So one of the use cases that I immediately thought of talking to them is in product search. Let's say take Amazon data or any e-commerce data. We apply these conceptual spaces and learn a conceptual spaces model on their data. So in fact, we can actually do lots of we can give many relevant results to users based on these conceptual spaces in product search, which is again a very domain specific area. However, learning entities and their relations in these product search perhaps would be very useful. Why? Because products keep on changing over time, new products are introduced. So maybe some kind of a temporally aware conceptual spaces would be very useful in such scenarios. So yeah, this is one use case and probably an extension to these conceptual spaces, which, let's say, people in the e-commerce domain can actually adopt.
Yeah, and actually on that as well, that I guess it's going to give significant competitive advantages to certain suppliers, kind of referral places and stuff, where actually they give really good contextual information. So interesting to say about Amazon, because you kind of often think that Amazon are going to be the dominant force in that. Have you seen it with any other e-commerce organizations? And by the way, I'm conscious as well. The sun is whizzing around, so I'm just going to do this because there you go. It's contextual information from the sun was telling me it's lovely outside. So have you seen any commerce organizations which have really fallen in love with this yet? And we've got a minute left, so just tell me about anyone.
After Amazon, I did not talk to any organization who would be interested in using conceptual spaces, maybe because they find it too difficult or they don't find it very straightforward to apply it in their domain. However, let's say going into the technicalities of it, it's not that difficult to use these conceptual spaces into your domain. Maybe because we wrote a very technical paper, that's why.
Fantastic. Well, Shoaib, thank you very much indeed for sharing your research and your work with us. Absolutely fantastic. I love your penguin behind you there. Thanks very much. We didn't even get to talk to the penguin. Is it a penguin? I think it is. It is. Anyway, so thanks very much, and we'd like to thank you for taking part in the AI Festival. Thank you very much, Shoaib.
Thanks, Adam.
And now for our next talk, which is on advances in predictive monitoring of assets. I'm delighted to say we're joined by three people from the University of Essex. So we have Reza, Hossein, and Faiyaz. Reza, I'd like you to take us through your presentation. Thank you very much.
Yeah, thank you. Yeah, thank you, Adam. Hello, everyone. My name is Mohammad Reza Khosravi. I'm Internet of Things Research Scientist in University of Essex. And in this project I'm going to present, I'm a KTP associate. And for full information, this KTP associate, it means we're working on the KTP, which is Knowledge Transfer Partnership, which is the partly government-founded program to encourage collaboration between industry and universities for innovative industrial solution in the United Kingdom. It means this project I'm going to explain is part of this KTP project. Okay, this project is about predictive maintenance solution in the facility management industry that we're going to present. The project leads that we working together with Dr. Hossein Anisi from Essex University and a specialist in the IoT and wireless sensor network. Dr. Faiyaz Doctor from Essex University is expert on machine learning and AI. My colleague Cody Yang, which is helping me on the machine learning part in the project and implementation. And also myself that I'm managing the wireless sensor network, the hardware design and IoT. The industry partner that we are implementing this solution for them is the Mindset Cloud FM Group, which is the only FM specialized in multi-site operation in UK and Europe. And they're serving lots of customers like ZZ Restaurant, NHS, KFC, and many other famous brands in UK and Europe. Okay, the goal for this project that we are trying to achieve, it's predictive maintenance zone. You know, it means we're trying to get any error or asset fault or any asset error in this green zone area, which you can see in the slide. It means that this area, which is cost to repair, is much lower than to the reactive maintenance zone. We are trying to monitor assets for any fault to be detected in this area. It means this area, the cost of downtime is cheaper, the cost of repair is cheaper, and also we can manage the asset line life. It can be, longer the time that it can work in the factory or in the industry levels. And the solution we have designed for this industry is that you can see in the picture is an IoT and AI solution architect for FM industry. As you can see here in this slide, we designed a hardware and sensors that you can detect and monitor and collect data from assets in a variety of levels. For example, in this project, we're collecting data from power consumption on assets, and temperature and humidity level on each asset, and also vibration level for those machines they're working on the motor or they're having working on mechanical asset they have. All this information through the wireless sensor network with LoRa technology that we use, transferring to the gateway, and from gateway, this information pushing to the web. In the website, we're having the variety of applications like UI in the mobile or web UI or mobile UI. We're having data storage and reporting system, and definitely as well as we have a machine learning in back end in the cloud that you can analyzing the information and data we're collecting from each assets. As you can see here, the case study we have used is the one of the project that we have from NHS, which is the monitoring the COVID, the medical fridge, which mostly they're using it for medicine and these days for COVID vaccine, which playing a big role in this NHS now. We are trying to monitor this fridge for any fault and error to save a large amount of medicine that this NHS lost every year because of this power failure or temperature failure on this fridge. We're trying to protect them for this kind of loss. As you can see here in this picture, we have a simplified version of the fridge in the picture for better understanding what we're doing now. We are monitoring 3 sensors, collecting data from 3 sensors in the system. We're monitoring the compressor, how much energy it consumes. We are monitoring the internal temperature sensor in the fridge, and also, as well as we check the ambient temperature around the fridge. It means the room that this fridge is located. All this information is collected, and we run the system for several months, and we find out there is the good pattern or abnormality detection method that we used to be able to detect fault with 2 factors that we can read here. We can read from the sensor. For example, here we're reading electricity consumption from the fridge, and also we're having ambient temperature in the room. By these 2 factors, we are able to predict the temperature inside the fridge. As you can see in the chart, the blue color is showing the prediction model, and the red color chart is showing the actual data. You can see they're following each other. And as soon as these 2, the differentiate between these 2 charts increased, it means we are expecting to any fault in the system. It means it can be anything. It can be a rubber door loose, a seal, or it can be power failure. It's, you know, we're changing this pattern, and automatically the system can detect this fault by, with this method that we're using, abnormality detection. And if you can see in this picture, we're trying to diagnose the asset performance parameter in real time. And by this system, we managed to create a dashboard that you can see in this slide, that we made the live data from each asset in different levels to be able to compare the predictive model with the real data that you can see is live in the system. For example, here you can see the yellow color, it's showing the predictive, and the green one is showing the real information. You can see they follow each other. And we're having the second chart, it's showing how much the predictive models is far from the real data. Whenever this information or this differentiate increase more than, let's say, the 1, then we understand there is some fault, or there is some potential fault in the system. And if this differentiate increase more to maybe 2, then it means the system need or the fridge need immediate actions to be taken, because maybe the result can be a totally fault or totally shut down in the system. That means the operator or engineer can go and check the fridge. By this system, we believe we can save lots of lots of medicine in the NHS, and definitely we can save lots of vaccine that we needed now for patient, and definitely the result is saving life. I mean, with easy solution, combination of AI and machine learning, we are able to save people life, especially in these days that we need this kind of system to make sure everything is in the right place. Yeah, it was this very brief solution what we're doing in this NHS project, and hope it goes well and we can install it in entire UK. Thank you.
Brilliant, thanks, Reza. And also, it's great to have Hossein and Faiyaz with us from the University of Essex as well. So I've got some questions, but first of all, I just want to reflect and say, you know, it's brilliant you're doing your part to inspire people against the fight of COVID, and using, you know, predictive monitoring of assets. You know, it's just great to see real life things come through like this. So I've just got a few questions, and we've got some time after that great presentation. So I'm going to start off with my first question, which is about the IoT system. So how would the IoT system assure quality of service, energy efficient mechanisms in development and deployment, really, and what are the wider implications in other domains? So, you know, how will it be used, and what are the implications? So I'd love to know a bit about that, actually.
Yeah, thanks for the question, Adam. Yeah, Internet of Things let us generate a smart monitoring and automation systems to enhance facility management and productivity of the entire team. So in this project, the IoT system enables the managers to track and monitor multiple assets and operation simultaneously and drive new insights using the data provided by the sensors. So for this system, we have developed lightweight and efficient IoT module, as well as reliable and delay sensitive communication system to ensure that the right data is transmitted at the right time. And the Iot system also empowers predictive analytics and provides alert about faulty assets or dangerous situation automatically with no human supervision. And yeah, as a result, the Iot system reduces operating costs and help the facility managers improve their businesses.
Brilliant. Okay, and following on from that, it's around the methodologies, really. So, tell me a little bit more about the AI methodologies being used for asset predictive monitoring. So, give me a sense of how that works.
Thanks, Adam. So, the AI monitoring aspect is split into two parts. We have predictive and prescriptive monitoring. With prediction, we're looking at the multitude of input data points that are being created from the sensors that are deployed within each of the assets. And here we're talking about multiple assets that are deployed over different sites. So we might have a number of different kitchens or number of warehouses where these assets are deployed. So the numbers of assets then goes up quite significantly. What we're trying to do, as Reza has pointed out in his presentation, is that we're trying to model the normal operation of a system, and we use the data points more or less form a sort of predictive model, and we use machine learning techniques such as deep learning approaches. And deep learning approaches, neural network based approaches, are used for essentially predicting the time series data that is produced from the sort of input parameters that Reza has mentioned, the power consumption, the rise and fall of temperature, etc. So that is the first part, the predictive modeling. The second part, obviously, is we want to be able to recommend what to do when a fault is detected. So here we're starting to apply more qualitative modeling approaches, specifically focusing on fuzzy logic techniques, where we can determine to a degree of possibility and probability the degree of risk associated with a particular type of fault likely to occur in a specific time window. So we're looking at the combination of low-level machine learning approaches like deep learning neural networks and higher level machine learning and data interpretation approaches like fuzzy logic in order to create a predictive and prescriptive modeling, which is also in some sense explainable to the end user in terms of what the fault is and how to what recommendation the system is suggesting to take in order to prevent it.
Brilliant. Okay, really good. And I'm sure the people at the conference, the IO conference, will be fascinated by that. It's it's amazing to see how far how far along you are with this technology and taking into those real life scenarios as well. So another question. We've got about a couple of minutes left now. So what different technologies do you see merging in terms of the future of FM and wider context of facilities monitoring? Where do you see that going?
I think from my perspective, there's been a growing interest within this sector and with respect to the merging of AI and machine learning at a low-level sense, and with other technologies such as VR and AR, and also simulation approaches. So with simulation techniques, we're talking about the concept which a lot of people may have heard of is digital twins. We want to create a digital representation of the real physical world. And we want to be able to use that in order to play out different complex scenarios and also formulate different prediction as well as optimization methodologies where we can not just predict what's going to happen, but also optimize the overall process in order to improve efficiencies such as cost, energy, etc. So I see a kind of a mixture of those technologies, and the VR and the AR technologies allowing us to augment and merge real situations in the field with those with the use of VR dashboards that people can be more immersed in. I think Hossein has probably more things to add in terms of the sort of IoT aspect that can come into this.
Yeah,
Hossein.
perfect. So Hossein, we've just got like 20 seconds or so, so real high level stuff. What extras you want to add to that?
Yeah, thanks, Faiyaz. And yeah, just quickly, I just believe that in the future of FM, thanks to the recent advances in 5G, wireless communication, and industrial Internet of Things, every asset would be able to communicate, interact, and talk, and without any human supervision, as I said. And also, they would be able to think, decide, and predict using artificial intelligence. So in future, we will have a fully automated system in which the assets do all the required tasks independently and shout for any help when there is anything wrong with them.
So for our final presentation, Jinya from the University of Essex is going to talk about AI robotics empowered autonomous systems for agri-tech and beyond. So Jinya, over to you. Thank you very much.
Good afternoon, everyone. My name is Jinya. I'm a lecturer in computer science and electronic engineering at Essex. So I'm very pleased to be given the opportunity at AI Festival to share my research on AI robotics empowered autonomous systems for agri-tech and beyond. So I would like to first use one slide to have an overview about autonomous systems. So the autonomous system here are not fully autonomous, but rather developing systems that gradually less rely on human involvement. So the autonomous system can be an air vehicle, ground vehicle, or vessel, etc. So autonomous systems rely on a range of sensors to interact with the environment, such as onboard sensors for its operation, the GPS, the IMU, and accident sensors to understand the environment, such as the camera, the LiDAR, etc. So sensor exploration is inevitable for data collection and analysis. So within the sensing data, the next step is to situation awareness, which transform the low-level data to high-level information. Then with the information, we can make the optimal decision. Followed by decision, we can using control action to implement the decision by the physical systems. So we can see there are generally 4 key elements in autonomous system, including sensor exploration, situation awareness, decision making, and control action. In all these elements, domain knowledge is very important to guarantee a satisfying performance. Domain knowledge can be the GIs, the rule of operation, the regulation, the wide information. And in some application, human operation is also involved, such as driving a vehicle, operating a UAV. So human-machine interaction is also very important. So to summarize, the autonomous system here is a closed system from data to information to decision and control action. And the objective for developing autonomous system is to improve the safety, autonomy, smartness, and sustainability. So in this following slides, I will introduce the application of autonomous system in a number of industries, such as the agri-tech, the future of mobility, the industrial inspection. So I will start with agri-tech. So why I do research in agriculture? Agriculture is facing a number of global challenges. So firstly, it's predicted that the world population will increase to 9 billion by 2050, resulting in 70% increase of food demand. There will be less labor for farming due to an aging society, and also the Brexit issue for the UK. And the urban land and natural resources are keep decreasing, especially the water. We have facing the climate change problem, and we should use less pesticide and fertilizer due to the environmental pollution and growing agricultural product requirements. So how to tackle this challenge? And the solution and objective is we try to improve the agricultural productivity and the sustainability. So funded by 2 STFC projects and 1 BBRC project. We have developing precision agriculture framework by leveraging satellites, the drones, the rotating drones, fixed-wing drones, the camera, the multi-sphere camera, hypersphere camera, and the IoT on ground for the ground truth data. We're also using machine learning deep learning algorithm for decision making. We also use ground vehicle, the drone, to implement this strategy. So in terms of precision agriculture framework, we start from the field. We use different sensing precision system to obtain information. We process and interpret information to get a spatial and temporal variation for the crop, for the soil factor in the field. Then we make decisions regarding the water, fertilizer, herbicide, and pesticide, and finally implement the vehicle and machinery. So in precision agriculture, the treatment map is based on stress map rather than implemented in a uniform way. As a result, we can see there's less input, the water, nutrition, with more output, the quantity and the quality, and less human environmental footprint due to reduced pesticide residue. So we have conducted a number of case studies in this field, such as the satellite mapping for the crop, for the vegetation, and snow coverage mapping. We're also using UAV for yellow rust, the black rust mapping and detection, and also the water stress. We're also using UAV to estimate the density of grasshopper. And recently, we developed a drone spraying system to automatically implement the target treatment. So the second example of autonomous system is intelligent vehicle, funded by 1 million EPSS project, leading by Loughborough University. We have developed a number of functions for intelligent vehicle, such as we develop system using retrievable analysis to monitor the status for sensors and aperture. We also monitor the status of the driver by using machine learning algorithm. We develop automated line change decision by using game theory, and we develop disturbance observer-based control for control the UAV. And the purpose of developing this advanced function is try to improve the safety, autonomy, efficiency, of about better future mobility. And these results have been accepted by some leading journals in this field. So the next example of autonomous system is in industry inspection. Recently, I'm working with about 3 companies at Loughborough University. We have one innovative UK project entitled the Follow PUA, developing autonomous UAV with spatial awareness for improved image quality for solar farm inspection. So in this project, we developed autonomous drone imaging system to automatically collect data, high quality data for the solar farm and detect its defect. So in addition to solar panel inspection, we also developed residential solar energy by using satellite. Satellite has some spatial resolution within several meters, so we can detect the mapping of solar panel, residential solar panel. I think in this field, the developed system can also be applied to a number of applications, such as power line inspection, the wind turbine inspection, offshore oil gas, and this poses many collaboration opportunities. So to summarize, my research is on autonomous system, and we rely on 4 key elements, including sensor exploration, situation awareness, decision making, and control action. And the technique we use including image processing, basic fusion for sensor exploration, machine learning, deep learning for situation awareness, data assimilation and optimization for decision making, navigation, guidance, autonomous control for control action. And the examples we are working with including agri-tech, intelligent vehicle, and industry inspection. And research is funded by EPSRC, BPSRC, STFC, and University of UK. That's a summary for our research, and many thanks for listening.
Perfect. Brilliant. Really interesting. Thank you very much. And some great kind of use mix of tech and agri-tech there as well. So it's just nice to see those worlds come together and looking at how we can improve crops and harvesting and so forth. But I've just got some questions in time we've got. So first of all, I just want to ask, so in precision agriculture applications, what opportunities can satellites provide to us, and what are the possible limitations alongside that?
Yeah, there are actually many satellites data sites which are free of charge. So such as the Sentinel series and also Sentinel series from the European Space Agency and also Landsat series from the US. So satellite remote sensing, the advantage of it is it can cover large scale compared against human survey or using UAV. But there are also some limitations. For instance, one limitation is about the spatial resolution. So the best ground resolution of freely available satellite is Sentinel-2 from European Space Agency, so which is 10 meters. But by using UAV, we can obtain centimeter level data site. So second problem is a cloud, especially in the UK. There are many rainy days and cloud days. So cloud is the second big problem for remote sensing satellite. But there are many satellites, and some satellites not have this problem, such as SAR satellite.
Yeah, I understand. I know everything about clouds in the UK. So, but I mean, in some of that, some of the sensing technology. So, obviously, parallel to that is the camera technology. So, in the agricultural tech area, what are the advantages and disadvantages of like multispectral cameras compared to like traditional common RGB cameras? What's the kind of main differences there?
Yeah, there are many differences between multispectral camera and our common RGB camera, such as from our phone. So in terms of advantage, I think multispectral camera has some extra band, such as the near infrared band, the temporary band. So it can detect some invisible symptom of crop disease. For instance, if we using the RGB camera, we can't see the temperature information, but using multispectral camera, we can detect the temperature. So in addition, the multispectral camera is less affected by the environmental variation. For instance, we can measure in the morning, we can measure in the afternoon. Regarding some disadvantages, one thing is about the price. The multispectral camera is usually more expensive. And the second advantage is the spatial resolution is relatively low compared with RGB camera, especially for the temperature thermal camera.
Yeah, and I think for us within BT, we see a lot of kind of advantages of drones. We've had quite an active kind of use of drones ourselves, and actually anti-drones. So there's almost two sides: there's pro drone and anti-drone, which are both fascinating for us in terms of protection and use. But going on to that thing about kind of let's just focusing a tiny bit more on drones. So pesticides. So you mentioned pesticides spraying using drones. What's the academic status of these then?
Yeah, there are actually already many drone spraying systems on the market, which can support nearly autonomous spraying with some human involvement, such as we define the route for UAV. However, how to guarantee the satisfying deposit distribution is still under investigation, particularly because there are so many factors can affect the deposit distribution, such as the environment, the temperature, and also crop conditions. For instance, if the crop is very small, we may fly very lower. If the crop is very higher, we may fly rather higher. So how to guarantee the satisfying deposit distribution under these different conditions is a challenging problem and still under investigation.
Yeah, so taking it from like kind of up in the sky to down to the ground a bit. So what are the challenges of autonomous vehicles, sort of on the ground level? What's those challenges?
There are many challenges in autonomous vehicle, but technically speaking, I feel how to guarantee the safety issue and the uncertain and dynamic environment will be the top one, because this is particularly true in some urban environments due to the involvement of pedestrian, the bicycle, or other surrounding vehicles. The second one is how to guarantee safety in some extremely environments, such as the raining and the snow days, like a few days before. So my research is how to improve the safety of intelligent vehicles by developing different algorithms.
So thank you, Jinya, and also to everyone within the University of Essex for their presentations this afternoon. It's been a fantastic set of presentations and a great one to finish on as well. I do love a drone. I've got one in the back of the car. I never fly it. So enjoy the rest of the AI Festival, and thank you very much, everybody. Thank you.